Next two things we're going to talk about are direct variation and inverse variation. So we'll start with direct variation. So basically two things vary directly with one another. So as one goes up, the other goes up, and they go up by a constant amount, or as one goes down, the other goes down, and it goes down by a constant amount. So looking at that in form of an equation, we get y equals kx. So notice that our slope is k. That's often referred to as our constant of variation, the constant amount that things are varying or changing by. Notice that we do not have a y-intercept, so it's like our plus b is 0, so our y-intercept is always going to be 0, 0. So we're always going to contain the point 0, 0. So we want to look in some different ways at A, determining if something varies directly, and then B, we want to look at being able to write an equation for a situation that we know where one variable varies directly with the other. So starting by looking at these, we want to determine if y varies directly with x. Well, notice that in order to vary directly, I'm going to change by a constant amount each time. So if I look at each of these equations, I notice, how do I get from 2 to 8? Well, 2 times 4 equals 8. How do I get from 3 to 12? 3 times 4 equals 12. How do I get from 5 to 20? 5 times 4. So notice each time I'm getting a y value by taking 4 times my x value. So notice to answer the question, does y vary directly with x? Yes, it does. This is direct variation. In example B, however, I notice that how do I get from 1 to 4? Well, I do 1 times 4. How do I get from 2 to 7? Well, it's not in the same manner. I'm not doing times 4 anymore. So I right away can see that this doesn't vary directly. I don't have that constant of variation. If I were to work through it and find the equation, I would find that the equation is y equals 3x plus 1. So I notice that no, this does not vary directly. And the way I'm finding that equation is going through that, finding the slope, y minus y1 equals m times x minus x1, which you'll see an example of further down. Looking at example C, does this vary directly? Well, if I get y by itself, I can get y by itself by multiplying both sides by 5 over 3. So notice I get y equals 5 over 12 x, which is in the form y equals kx, so I can go ahead and say, yes, this does vary directly. And then finally looking at example C, if I were to get y by itself, notice I would get 4y equals 10 minus 7x. So y equals 10 over 4 minus 7 over 4x, and I can see that since my y-intercept is not 0, that no, this does not vary directly. As I mentioned before, we also have to make sure that we can write equations. So in the second example, A, B, and C, we're going to go ahead and we're going to write an equation to represent my given situation, and then we're going to go ahead and use that equation to find y when x equals 6. In your practice work, you're going to be spending quite a bit of time looking at something like this. You're going to be given a situation and then asked to find y when x is some other number. You can do that by first finding an equation and then plugging it in. So to find an equation, I'm going to go ahead and first find my slope, my constant of variation. So A and B are tied very closely together. So I'm going to go ahead and say m equals, I'm going to go ahead and do y2 minus y1 over x2 minus x1 using my slope formula. How do I use my slope formula when I'm only given the point 0.34? Well, because as soon as I'm told that it varies directly, I know that I also have the point 0.00. So I'm going to go ahead and say 4 minus 0 over 3 minus 0 equals 4/3. There's my slope. I can do y minus y1 equals m times x minus x1, but really all I need to say is y equals my slope, which is my constant of variation, times x, because remember, if I vary directly, I'm in the form y equals kx, where k is my slope. So my constant of variation, I'm just picking my slope out, it's 4/3. So find y when x equals 6. When x is 6, y equals 4/3 times 6, which is y equals 8. So any questions you have on this, please make sure you bring it in. I did post a video from Khan Academy to remind you on how to write an equation if anyone wants to reference what am I talking about when I'm saying y minus y1 equals m times x minus x1. I would encourage you to check that out if you don't remember how that looks.